This conference will now be recorded.
So, photogrammetry and real. I'm sure those who have been to the summer and winter conferences that we have down in London will have heard the likes of Steve Featherstone saying that drone survey is the way forward. This is what we're going to be doing. We'll never have to send surveyors out to site ever again, so on and so forth. I've witnessed myself the big push that folk are clambering to use this drone technology for topo surveys, and I thought it's a good subject just to get people to understand just how much maths is involved in photogrammetry to just locate one point on the ground. And then when you're trying to, as I go through this, just think how to apply that to finding a rail position 14 mil down the side of the head of the rail. And just have that in the back of your mind as just a wee sort of precursor. So normally I don't like reading out what you see on the screen. We're all engineers, we can all read, but because this is a slightly different format, I actually have written down most of what I'm going to say. So it goes sort of hand in hand. Unfortunately, the way the screen's set up, I can't see it. So, excuse me a second. Right. They say a picture is 1,000 words, and you can't argue with that. That's why we use drawings. As engineers, we use drawings. We don't transcribe how we think a building is going to be set out. We don't transcribe the railway that you go straight for 100 meters, then you'll take a slight left, then an increasing left, and then maybe straight again. We draw because it's easier to convey what we want. The camera never lies. It's another one of these well-known cliches, but it's true. If you take a snapshot of something, that is generally what you find is there. Obviously, there's whole editing and filters and all that sort of good stuff going in the background, but if we part that to one side and just say, this is a photograph, as if it's, we used to call it photographic evidence. So if we take that as still being holding true, it's a good way of actually determining what is or isn't there at an epoch in time. So photogrammetry is not new. It's been about for years. As I said, their first photographs were taken in 1839, and in 1840, somebody tried to create a map from it. So why wouldn't you? You're up, you've got that bird's eye view, you can look straight down. It makes sense, doesn't it? You look at something from above, you get that whole sort of simplified view. That's why we use plan drawings. So why wouldn't we want to use photogrammetry in rail? Well, there's a lot of maths, and I'm just about to go through some of the maths to just explain why you have to just be careful. Not saying don't use it, just saying be very careful. So what are we doing? There's some key points and terminologies that are recurring themes. So principal point, and that is what should be the image center. Isn't always, because you've got a little bit of distortion sometimes in the camera lens. You'll hear me talk about oblique photographs. That's when they're sort of taken side on. You can have a high oblique or a low oblique, depending on if you've got the horizon in or not. The nadir, I can never work out which one, how to pronounce that. That is when the camera is pointing straight down. That is the crux of photogrammetry. That's all these principles are based on that camera pointing straight down. We've moved on from that using techniques called structure through motion, where we start using oblique photographs. I'll come on to that later on. And then you've got a thing called side and end lap. That is just basically how much of that picture you overlap with. The reason we need that is a thing called stereoscopic, which is essentially how 3D works when you go to the movies. If you've ever taken your 3D glasses off, you'll see it's either two different colours or it's shot from two different angles. Generally in the movies it's two different colours because they can then filter with the lenses. Some fancy high-end televisions at home basically have it from two different angles and they shutter the lenses in your glasses. first principle we're working on, that of similar triangles. So what we've got in the little presentation there is just point A, point B, point C as they appear in the ground, and those are reversed as it goes through the camera and hits the image sensor. It sounds basic, but you've got that focal length, so the smaller you've got, the longer your focal length, then the smaller the angle is in the ground, the less you'll see, but generally greater detail, and obviously the wider your focal length, the more you'll get to see. And that's pretty much what we go on to say. So we can work out from our photographs the scale factor of the photo, and that's what we've done there. The 2 points on the ground, using similar triangles from the center point or the principal point, you can work out the distance. If you know the distance of focal length, you can work out all the angles, and it's trig. There's lots and lots and lots of trig. And don't worry, I'm not going to go into the trig because I can't remember half the formulas, if I'm honest. It's one of these ones I always have to go back to the reference books. So I'm going a little bit fast here from my liking. So we've got a thing called scale factor. So that is if you take a photograph and you have a known distance on that photograph, say it's a pair of rails, you can work out the scale factor of that photograph based on the distance between the two rails. We know is 1435-ish, and we can use that and apply that across the photo in general, providing the photo is all at the same height above the datum. So if it's a flat piece of land, yep, fine, you can work that out. So, and that's pretty much what's shown in these two sketches here. That you've got line 1 and 2, it appears to be the same size as line 3 and 4. However, when you actually look at it in profile, line 3 and 4, not only is it closer to the camera, therefore it's got a different scale factor, it also has a dirty great big peak in the middle, which you'd actually have to measure up and over. So these things aren't obvious in photographs, especially in their photographs. It's really hard to tell relief. And every time something changes, then that part of that photograph has a different scale factor, different set of calculations to work out. Because without knowing your scale factor, you can't work out your coordinates in the ground. So just to prove that, that's an area, one of the photographs I've got taken, and it's asking the question, are we looking at something that's an cutting? Are we looking at something that's an embankment? Are we looking at something that's flat ground? Do we know? Can we tell? It's really, really hard to see from that photograph. So another thing we can use is a technique called relief displacement. So if we look at the lamppost in that photograph, relief displacement, it's another theory, and again it works on similar triangles, and this time it's rather than parallel lines, and we're looking at radial lines from the center point. So this lamppost that we can see actually looks as if it's leaning out, so we can actually tell that that lamppost is higher than the ground around about it. If it was to lean in, then we know it's actually lower than the ground round about it. And it's items like that we're starting to use, and little bits of that type of technique that we apply to try and work out heights and various other bits and bobs. You know, you can see the lamppost, you can see how it leans out. And that slide shouldn't have been in there. So what we have to do once we've got our raw photographs and we try and work out our scale factor is we create these things called ortho rectified photographs, and that's what you're seeing on your screen just now as an ortho rectified photograph. Ortho rectified means that it has taken into account all the various scale factors. It's also taken into account any tilt in the photograph, and it tries to create a best fit representation of what is there so it can be used for engineering purposes. But it's only a two-dimensional photograph. Now you can see on the right-hand photograph, it's the same image. However, the lamppost is now almost vertical because it's taking that tilt, it's taking that relief displacement out of the photograph. So ortho rectified photographs, great for backcloths, but they have no elevation to them. And really we need elevation. Because as I said, the world isn't flat, but our image sensor is. So there's a thing called stereoscopic parallax. Now that's, in its most basic term, we'll all came across it. It's when we look through a dumpy level and we've not adjusted that the little eyepiece properly. And when you move your head, it looks as if the staff's moving and the numbers are moving. Essentially, you're viewing a point from, a fixed point from two different angles. So we flip that. We can actually view, rather than having our staff as being the fixed point, if we actually have two photographs of the staff, we can use the same parallax principle and equations to actually work out where things are. It's essentially because that's how our eyes work. We're viewing something from two different directions. We know the distance between our eyes. That's for we can do the depth of perception. So if anybody wants to try this one, the little bit on the bottom right hand side, close one eye and see if you can tap the monitor, the corner of the monitor, and maybe put in the chat how close you came to actually touching it, or if you came short or not. So we also, we're still using trig, and everything we're doing is based on trig when it comes to cameras. And everything so far, we're looking at just creating one coordinate value for one point in one photograph. And that's where things start getting really, really complicated when you've got millions of points, and millions of coordinates on your photo that you want to map. So the first thing we need to do is we need to remove all our calculations that we do to create our principal points, to create our relief displacement, to understand where anything is, to understand our verticalities are. Because it relies on the photos being perfectly flat. If that camera is slightly tilted, then rather than having, basically because it's using similar triangles, all your angles about, therefore your measurements will be out. So we actually have to understand how much yaw, tilt and roll there is, and then remove that from the photograph and then start our calculations. But it is possible, and we know we can create X, Y, and Z from it. It's just quite tricky. There's a reason, and this is where I'm coming back to it. There is a reason why it's used extensively in mapping, but we don't work in maps. We work in engineering drawings. There's a bit more flexibility in mapping. There's a lot more flexibility in mapping because you're allowed to move things. You don't worry too much about scale. A 1 in 1,000 map means that the smallest entity in the ground, we need to be a metre wide before it goes in the map. But we know fine well they show streams, we show fence lines and hedges and things like that, which all may be under a metre, but we're allowed to because it's a cartographic license allows us to do that. So for mapping, photographs are brilliant. For engineering, yeah, I'm always concerned that we forget to carry the one. But that said, we've got drones now. And drones have been quite the game changer in that using a drone system, we're actually able to locate the camera using GPS. That's really hard to do with a fixed wing aircraft because it's flying so fast. And we're able to actually mount cameras on gimbals underslung. Now gimbals are basically a 3-axis motor that makes sure it's either, you want it straight down, it works out straight down. It uses gyroscopic corrections and understands where it sits. They do fly off course a little bit more, but it's a good balance to have. And we know, as I said, we know where the angles are, and we know where the camera's pointing. However, we also move away from a film sensor to a digital sensor. A digital sensor is basically an array of pixels. You either get turned on or turned off depending on how much light they receive. And since we're working in angles and we need that resolution, if your pixel size is too small or you're flying too high, you end up with pixels that have multiple information points in it. So it's a kind of conglomeration. And if you're doing that, then you're not working to the same angular resolution that you might need to. So I've stuck two photographs. They're the exact same photograph. One's pixelated, one's not. So in the bottom one, you can see it's nice and sharp. We can tell where that buffer end is. And the top one, can we tell where the buffer end is? We could make a good guess, but that guess is going through our angles and going through our calculations. Therefore, our accuracy is dropping down again. And when you're looking for, the sub 5mm that the track standard asks for on a point of the rail that's 14mm below the running edge, the running head face on the running edge, it's really hard to try and work that out. We're also very reliant on ground control. Again, this is all, get it wrong and it dilutes the precision, it dilutes your accuracy, and it means that you're getting further and further away from engineering and closer to mapping. Now we can use GPS, we can use ground control, we can use a mixture of both, but even with the ground control, that white cross, that's quite a broad cross. If I'm looking for a millimetre accuracy, I need to be able to pinpoint the centre of that to a millimetre. So again, it's just like one of these things, be mindful of how you're going to put your control in, where you're going to put your control in, and how accurate you're going to be able to locate your control. Again, there's no point in having that cross to, the millimetre perfection if my pixels aren't going to basically pick it up and I get it as, it goes across 6 or 7 pixels, or it goes across, the whole cross is in 1 pixel. So again, it's another thing just to be careful, just to consider. We can use other things. We do use pixel matching. That's where the computer system looks not only for the point you've picked, but it'll then look round about it and it'll look at its nearest neighbour, and it'll work out not just the colour of that pixel, but it'll look for, well, that pixel's white, the next one's light grey, then gets darker and darker and darker, in all 4 directions. It will look for that when it's in subsequent photographs, because we're now looking at actually how do we stitch all the photographs together to create a single, either an ortho photograph or a 3-dimensional mesh out it to get our height information. Like everything, the more control you've got, the easier it is for the software, because you're telling it you're fixing those points. But the reason why when we put ground control out for topo surveys, we're doing it every 150 to 200 meters along the track. The more information you have of known points, the better the fix is. So I mentioned briefly about oblique photography. Oblique photography is an absolute game changer for us. That has taken, it used to be used just for context. So that's that photograph I asked, is it in cutting or embankment? You can actually quite clearly see what it is using oblique photography. But now we're actually able to use the gimbals and actually understand the pose of the camera. It means we can actually start using oblique photography as part of photogrammetry purposes, rather than just using the nadir downward facing cameras. Prior to UAVs, yes, oblique photography was taken. There was cameras mounted inside the aircraft, but we didn't know where they were. And as I said, you need to know how much tilt there is in your camera system. Because if you don't know what that is, then you can't accommodate for it, and then you can't use the trigonometry again. So a picture is worth 1,000 words, but it needs millions of calculations. thing is, when you do get it right, it is very powerful, and there is a use for photogrammetry in rail. I would always shy away from using a drone as my only source of survey. I just think for me, there's just far too much maths involved, and the opportunity of just forgetting to carry that one and getting it all wrong is really huge. But there's a standard topographic survey that we get. That's the Lapfield Junction, for anyone that's aware of it. Hard to tell what it is, hard to extract any meaningful data from it. Okay, we've got our rail strings. It's got everything the designers need, but it really doesn't tell much of a picture, much of a story. That's the same survey, but this time I've taken the ortho photograph and I've overlaid it. So we can actually see that's, oh right, there's a third rail that crosses over there, or crosses underneath. We're in quite a dense area. Looks suburban. Well, we know it's suburban. There's a car park. I'm changing that half set of switches where I'm going to get my access points. It starts bringing context into your surveys, and that's where photogrammetry, for me, has such a benefit in rail. And we can take it another stage further. And this is where I'll be very quiet for a couple of minutes. The next video we're going to see has been done entirely from stitching photographs together, taken by UAV, and I think it shows just how powerful photogrammetry can be for our industry, but only when it's used with an understanding of its limitations. So what we're seeing there, those details that we're seeing from the survey, those were actually picked up by surveyors. That was done with a standard topographic survey, and the photogrammetry has been overlaid. It's been turned into a three-dimensional mesh and overlaid on the survey. So we've seen we can actually get it quite close, really close. The mesh was created independent of the survey, but this for me is where the power of photogrammetry lies. The usage of this for stakeholder management, whether it's class detection, whether it's site familiarization, just getting folk not to have to go and visit the site. You know, I'd like to think with these types of techniques, the days of having to go into Thursday night for a site visit are long behind us, because we don't have to. We've got that information. We've taken that snapshot. We've already said the camera never lies. That's how that site looked at that time that was flown. Now, I've rattled through this a lot quicker than I thought I was going to. Sorry about that. It's one of these ones that it's trying to strike a balance of how much detail and how much maths to go into. So with that, I'll throw it back to Russell for any questions.
Thanks very much, Colin. That was excellent. Thank you. So just to remind everyone, the chat forum is open, and that is the top right-hand side of your screen, hopefully between the participants and the settings, the little chat button. If you press that, that'll let you type in any questions for Colin. And while we're typing away, I've got a question or two myself, please, if I could start, Colin. one of them was you kind of answered that, and that was about the the facility for kind of drone usage and mobile footage and that looks like that's all in hand and not really an issue. What I was kind of thinking about was kind of weather issues. Are there just kind of standard items that affect most surveying? For instance, in rain or anything like that. Is it the kind of usual issues that affects all the surveying activities? Is there any difference with the weather conditions for this type of format?
Yeah, so I mean, you're using an optical sensor, so you're using a camera. It's like your snaps at the beach. They're always turn out better when it's nice and sunny. Wind is obviously a major issue for drones because the maximum weight for a drone to fly over the network while it's running is 7 kilos. It's not a lot of weight, so it's acceptable to sort of side winds. You get better results when it's nice, bright, sunny days. You get less results when it's dull and overcast, and if it's raining, then they might not want to send their drone up. But the framework suppliers factor all of that in. But generally, it's wind and heavy rain. Heavy rain, they can still fly, but your imagery would be really poor. So I know asking for a sunny day is hard packed, but as long as there's enough light for the photographs, then they can pretty much fly, unless it's blowing a gale.
Okay, thanks, Colin. I'll just remind everyone, Kate's popped up a little note there about just please post your questions here on the chat forum. So if anyone's got any questions for Colin, just pop them onto there, and I'll certainly read them out as we go through, etc. I was going to ask another question, Colin, if I may, type of thing, and it was about the kind of the usage so far within the industry. So it sounds a relatively specialist technique type of thing. However, how kind of broad is it being used just so far within this railway industry? And indeed, is it predominantly with sort of civil stuff, or is this being stretched out to other, as well as tracking civils, other elements? Do you have any experience of that at all, Colin, please?
Yeah, so I mean, there is systems available within the Network Rail framework contractors who can actually undertake a full topographic survey using a UAV. As I say, it's not something that I'm particularly keen on, but we're finding that it's been used in IP track. So that 3D mesh that you've just seen there, IP track, what was IP track, now track development, are using that type of mesh for their ITCs, IDRs, and all through the development process. Those photographs are from the Lecky project, which is probably the first major capital delivery one that we're starting to roll out on. We're finding that rolling programs for decarb are very keen on it as well, because whilst it's not particularly accurate enough to work for a track survey, and we are track people here, it's more than accurate enough to work out your effective depths for to survey your effective depths of a field, for putting overhead line masts in and things like that. So it's starting to gain traction. We're starting to realise that it has its benefits, and it's just one of these items where I think within the survey community in Network Rail, we're just trying to manage some people's expectations that it does some things really well and it does other things, but not quite as well. So yeah, we're starting to gain traction in Scotland. It's one of these things that the more folk that see it, the more exposure it gets, the more people are going, oh, that's really quite handy. I still pitch it as a context, rather less of a survey technique and more of a context and concept to actually bring the outside in. For me, there's still we still need to get guys to go out and pick up proper topo detail on site physically. The other thing it doesn't do, it doesn't go and lift the manholes up and tell us how deep our drains are. And it definitely doesn't put in PGMs for machine control when we actually get into doing digs.
Absolutely. Thanks very much, Colin. We have quite a few questions now, so I'll run through them.
So could I just have I was a bit disappointed with your introduction, Colin. So I thought you were maybe going to come in sort of music with Blondie and you'll picture this. So you know, it was a bit sort of quiet coming in. I quite like the idea of photogrammetry, especially to hard to get places, and especially up in Scotland that we've got red zone prohibited. It's something that is a good starter for 10. But do you feel that maybe it's a good tool to have, but it doesn't quite get rid of the need to go to site all the time? Because sometimes you go out to site and you get a feel for what the job actually entails.
So, as a replacement for going out to site, I think we're getting there. I don't think we're there yet. I think we could get there as a replacement for site visits. You know, you've seen a 3D mesh there, which is really good. You can put VR goggles on and walk through the site if you want. In creating the mesh, you lose some definition, but that definition still exists in the photographs. So I think we could, and sort of using COVID and changing the way we work, I think it should and it could remove the requirements for generic site visits. I like to get to the stage where the only people visiting site are the surveyors, and everybody else visits site virtually. And I think the photogrammetry is a way towards that.
It's I've got a new word in my lexicon, ortho rectified. I'm going to use that for a Friday night, I think, because that's a belter of a word. I've had to write that down as well. Yeah, there's quite a lot to it. I mean, I'm glad you never actually went into the maths, because I think that might have been a bit of a sort of mind bender for this time of night. But certainly, I've seen some of the sort of presentations. Chris Doyle showed me some bits and pieces, and he's been speaking to sort of people, and there's a lot of tools out there. I take it there's different tools, because I've seen presentations by, I can't remember who the company were, and it was sort of like a 3D picture as you were actually going through. So underneath the members of a certain bridge, and you can sort of get it from all different angles. And are you getting involved in sort of that sort of stuff as well through some of the design houses?
I can do, and very much I've not fully taken up my role yet, but that's the type of thing that I'm looking to push forwards where I'm in role. But yeah, I mean, there's all sorts of different types of photogrammetry we've looked at today. There's the aerial and the UAV type stuff. You can combine it with ground photographs, you know, and take structure of the ground photographs. It's more called structure from motion, but you can stitch them all together and you can create 3D renditions. So it can be the undersides of for bridges. You can augment it with point cloud information from scanners. It's one of many tools to actually help visualize. I still see it, whilst I don't see it as a replacement for survey, I still think it fits very much with the surveyors to understand the photogrammetry and to be the ones who advocate for when to use it and when not to use it. You know, the accuracy, and I know there's a few questions there regarding accuracy. The accuracy is down to your pixel size and how high you fly off the ground. So there is a company that does supply band 1A accuracy surveys, and they basically fly at really low to the ground, like 30-40 meters, with a huge amount of overlap and massive sensor sizes on the cameras, and that's how they do it. But they're creating huge amounts of data sets to create this. And sometimes it's, again, if you don't always carry the one, you may get a little discrepancy, and then it's always based on the control. So they still have to go and visit site, they still have to put control out.
That's all from me, Colin. Thanks for that.
No worries.
Thanks, Mark. Thanks, Colin. I'll run through the questions. The first couple were, as you say, Colin, about accuracy. We'll probably delve a little bit into them. The first one is from Graham Hutchison, thanking you for the presentation and asking, how do we, as the engineering community, check the accuracy from suppliers?
Yeah.
So,
Graham Hutchison, the other surveyor.
If there's any sort of formal accreditation or how we do that as a kind of, you know, how they can prove and demonstrate their accuracy from a sort of suppliers community.
So the suppliers will claim accuracies. It's a similar question to, you know, a survey company will always tell you to go out and they'll survey to band 1 accuracy. Now band 1 accuracy is, you know, the real position under at 4 mil, 5 mil, whatever it is. And are they doing it? Well, it's hard to say. By the time they've got an error, one of their setup errors, you know, they might have been lazy with their setups. They might have been lazy with how they held the staff. So accuracy is always one of these hard to measure things. But the simplest way that I measure the point cloud accuracies is I compare it to a topo, because I don't believe it as a replacement for topo. I would still get a topo survey done. So I can go and overlay the photograph, and if that photograph sits on top of my topo, then I know it's pretty accurate. If it doesn't, then I know it's less accurate. But I'm only really looking for accuracy of photographs within, you know, the 50, 60 mil. I'm not looking at for 5. I think when we do that, the cost goes up. Not only the cost of acquisition, but the cost of storage, the cost of manipulating the data. As part of the BIM, I work with the data management team, you know, and if we start going and get all this source data that's gigabytes of data, somebody has to store it and we have to pay for it. Do we actually need it? You know, a standard topo survey is only maybe a couple hundred kilobytes. Each one of the photographs that were created for Lecky are over 10 meg, and there's thousands of photographs on Lecky, and that's not even at the low altitude, high overlap flights. So how do we check accuracy? Baseline off something that we know has been done to a better level of accuracy. Measuring from the whole to the part. Gail.
Okay, excellent. Thank you, Colin. The next question was from Paul Ebbett, and he was apologising if he'd missed it previously, but he was asking about if you could advise the level of accuracy from a drone survey, i.e. like a plus or minus what. And I know you said that you just talked there about band 1 accuracy, and so is there a kind of a different banding, Colin, just for the levels of accuracy? Is that how it's set out, or that, or including drone usage?
So standard drone is either band 3 or band 4. So it is known to be a lower accuracy product. Again, the overall accuracy depends on how high you fly and how many pixels you have in your sensor and how good your control is and how good your maths is. That is the 3 things that affect accuracy. You could go and get low accuracy with a cheap drone from Curry's, fly it, get something that's probably going to give you maybe 200-300 mil, or you can get the Vogel system, which will fly, and you should get apparently 5 mil, but between 5 and 10 mil accuracy. So it all depends what you want and what you're going to use it for. So what we're using it for in capital delivery is the context and the mapping side. We're not currently using drones for topographic survey. We're using it for mapping.
Okay, thanks, Colin. The next question was from John Diddy, and John was asking how long did the East Kilbride survey take to capture and process, assuming it was done as a kind of continuous exercise to get a feel for how long that whole process for you know, like a branch line like East Kilbride took roughly? Any ideas at all?
Yeah, so I'm pretty sure it took about 4 weeks of flying. Again, because it's drones, you can, it can be one team takes 4 weeks, or 2 teams can take 2 weeks, or 4 teams can take a week, because you can just chunk it into little bits. I'm pretty sure for the Lecky project, we flew from just the Glasgow side of Muirhouse Junction down to Barhead, and then from Busby Junction right the way out to East Kilbride, and spent a fair bit of time round about Hare Myers, because they thought there might be a new platform, got a new station getting built. So it was about 4 weeks to do the whole Lecky survey.
And for anyone that's not too familiar with East Kilbride, I'm trying to think to tell, is that about maybe 7 or 8 miles or something? I'm just trying to get a feel for mileage roughly in the East Kilbride branch line.
I'm not sure. It was a decent enough size, because I think Barhead's at what, 7 or 8 miles, so that was like 8 miles down that route, and then whatever it is from Busby Junction to East Kilbride.
Okay.
It was a decent chunk.
Perfect, thank you. We have another couple of questions. The next one is from Jim Watson, and he would like to ask Colin how confident he is on the accuracy of profiling of earthworks and filtering between vegetation and the ground from data captured from LiDAR. Jim was saying that this was an issue on the SHOTS project where the output did not represent reality. So if there was any kind of vegetation in the way that was given some kind of false reading, have you had any experience or issues with that at all? Or?
Right, so it's a photograph, therefore it will give you the pixel, it'll give you the coordinate of whatever's in the photograph. So if that's a leaf, it's a leaf. LiDAR has a thing called a first and last return, and if it's set up properly, you should be able to penetrate some foliage, not all foliage, but it does penetrate some foliage. Photogrammetry doesn't do that. Essentially, whatever's in the photograph is the positioning coordinates. So if it's long grass, it's the top of the grass. If it's a bush, it's the top of the bush. If it's bare earth, it's bare earth. So it doesn't really do, because it is just a photograph. It can only pixelate what's there, and it can only coordinate what's in the pixels.
Sure. So I suppose all the pre-electrification devegetation would be sensible to try and get done early on, and prior to any extensive surveys as well would make a big difference.
Oh, totally. I mean, if we can go through and scorch the earth, that'd be ideal.
Yeah. Okay. We've got one last question so far. So again, if anyone has a question they'd like to add, just jump onto the chat forum, pop the question in, and we'll ask it out to Colin. So last question so far, Colin, from Alan Morrison. Thanks you for the talk. And Alan was asking about in recent projects that he's worked on, and they've used aerial surveys combined with conventional track survey equipment for rail positions. Is that likely to be the combined methodology for the future enhancement type projects? I think you kind of touched on that a little bit earlier, type of thing, in answering another question. So yeah, so a kind of hybrid between aerial surveys with conventional, is that what's likely to happen, do you think? Or?
If I get my way, and I know the project that Alan's talking about, if I get my way, that is the way forward. That we'll have aerial photography, meshing with the rail positions taken either by detail pull, ideally from a track measuring device, and a ground-based scan, be it helical or terrestrial laser scanning. That to me is a utopian position to get to. It gives us all the data we need, so that's where I'm pushing capital delivery to now. That is the method of data that we pick up. However, I need to, for me to push for that, I need feedback from our supply chain guys. So folk like Alan, if he thinks it's a good idea, I'd very much be keen to hear that, to make sure that I'm on the right track. with how I'm trying to get things done. We've got these capabilities. We've got our in-house survey team with Graham, we've got the scanning kit that we can use to measure, and it also gives us a little bit more level of detail, harking back to what Jim was asking regarding the LiDAR. You know, if you're on a tree canopy, you can only look down, you can only see the tops. If you've got a terrestrial scanner working helically from the ground outwards, then you can actually work out where tree trunks and things like that, and you've got a better idea of getting where the ground is. Again, if you've got long grass, the scanner will only scan what it sees. But to answer Alan's question, yeah, that's where I'd like to see us moving towards, providing I get the right levels of support and nods from the supply chain to say that I'm on the right direction.
Okay, Colin, thank you. There's currently no more questions just now. We'll give it another minute or so. See if anyone's got any other questions before we wrap things up, etc. And that. So is the survey community quite a reasonably compact and small community? You know, it's a similar amount of groups of people within the UK. Colin, is that kind of right in saying that, or you know, how are we doing in Scotland, for instance? Do we have access to that type of technology reasonably easily? Or?
So in Scotland, the survey community for Network Rail essentially is two folk, and it's myself and Graham who are trying to lead the charge. What I've noticed is that when I talk to supply chain, they're all for it. They're all for the scanning methods. They know where I'm coming from. They see where I'm wanting to do. The biggest challenge we've got is actually with the engineering community, because we are quite backwards in that we want to see drawings. We don't like working in models yet. And that's a bit disappointing, but it's one of the things that we'll get to. We'll move away from it. We'll start understanding that you're better off not looking at a drawing. You're better off looking at a model, because the model gives you the whole picture, whereas a drawing only gives you a two-dimensional representation. Sometimes it's two-dimensional plus vertical, but it's still only the outline of a location case, or it's an outline of something, rather than how tall things are. So it's a little thing we just have to move forward to.
Okay. Well, another question just popped in there. A question from John Oates. John is asking, can the system produce cross sections of the track profile at any chosen point? So,
it can, because for what we do in photogrammetry is we take the photographs, we ortho rectify them, and then to get vertical data, we produce a point cloud from these photographs. So that's essentially just coordinating every pixel on the ortho photograph and then giving it a height. So yes, you can cut through that as a cross section. How accurate your cross section depends on how accurate your flying heights are again. So yes, we can do it. Should we do it? Depends what you want to use it for. Would I cut through a point cloud to tell you how much cant we've applied? Good God, no. But would I do it to understand how steep my embankment is? Yeah.
okay, yeah, it sounds like a kind of pretty sensible way for a kind of cut and fill estimations, etc. Yeah. As we're going through the questions, if any of the feedback we've got from Colin, if there's any other additional points for any of the people that have asked the question, just pop another bit in the chat forum if it didn't quite answer exactly what you were after or anything. It's not easy to give feedback in this methodology type of thing. So, one quick question I had myself, Colin, just as we're moving along, was when the drone, kind of survey drone, flies over, you know, the railway type of thing, can that be done in a kind of operational mode, or is there any restrictions? Does it matter if it's electrified or not? You know, just to get a feel for, you know, when that type of survey, you know, if I know there's restrictions on regular drones, but you can't fly over a railway, but again, with a kind of license operator and that, is there any sort of special issues or restrictions, you know, even when we're doing it internally?
Yeah, so with our framework suppliers, but of which there's 4, and they're managed by the guys in Milton Keynes, they are allowed to fly over the operational network while the trains are running, providing their UAS is under 7 kilos. I think the reason 7 kilos has been picked is they've been tests done that under 7 kilos, it's not going to, the driver probably won't notice if it bounces off his windscreen. So East Kilbride was flown during operational traffic. If the drone downs, then they might want to go and collect it. You might have to go and take line blocks and stuff like that, or you might just tell them tough and let the train drive over the top of it. At 7 kilos, it's frangible. So as long as we're under the 7 kilo marks and we're using one of our approved framework suppliers who went through all the correct rigor, then yeah, it can be used during operational times. The East Kilbride was flown during the day, Monday to Friday. So when I say it was 4 weeks, it was 4 weeks of normal shift times. It makes it slightly interesting at times, especially when you get to dual stations. So some of my photographs for East Kilbride I had to delete because I was getting a lovely big train, DMU sitting on the platform, and it was coming into my 3D mesh. So I had to just sort of pull some of those photographs out so it didn't appear.
Sure, thank you. We have another question just popped in there from Cliff Pitt. Will these surveys be available for all disciplines, i.e. maintenance, or are they solely just used for renewals for the work bank kind of jobs? So can they be used by other parties, I suppose, of the business?
There's no reason why they can't be, but they are a point in time. And that's depending on how fresh you need your data, depends what you want to use from what you want to gain from it. But I'll be more than happy to have a chat with folk in maintenance and asset management to find out how we can use this to aid them. So nothing stopping it, but it's understanding what they want to gain from it.
And is there any kind of specialist software or hardware indeed, required to run this type of thing? Is it quite a meaty program to have on your machine?
Yes and no, because I'm slightly unique in that I take the raw photographs. However, when we're using it on IP track, track development, it's a deliverable. So the UAV suppliers are giving us the point cloud, they're giving us the Ortho rectified photographs, and they're giving us the scalable mesh that you've seen the fly through there at the end. But that's something we've asked them to do. So it is something the supplier can provide through the framework as an end deliverable.
Excellent, thanks, Colin. I think that's probably all our questions by the looks of it. So thank you very much for everyone asking the questions, and thank you, Colin, for an excellent presentation. You've given us a real good sound background information on the photogrammetry and that, and I think you started off the presentation by a couple of analogies of a picture speaks 1,000 words and the camera never lies, and that really set the scene with the equipment and indeed how it's going to be used as well. He talked us through the basics of the similar triangles and trigonometry, just to give us a kind of practical feel of how it works, which was really helpful, and reminded us that indeed the world is not flat, so which is always good to know. So, but yeah, it certainly puts a different perspective onto it, pardon the pun type of thing. I did try touching the screen with one eye closed, and yeah, I get what you mean now. So yeah, that's a nice practical example as well. Thanks for that, Colin. And indeed, when you see the raw survey data type of thing, and you showed us how that's overlaid onto the mapping, and then suddenly the real benefits start coming out there. So that was very helpful to see. And you talked about obviously 3D goggles, maybe virtual walkouts and that with indeed COVID-19, and indeed I suppose the reduced track access, which we're trying to strive towards to keep people off track that don't really need to be there. So that's an added bonus as well with the current way of the world as well. So that was really good to see, Colin. But importantly, I suppose you did say that it's not a strict replacement for a topo, and indeed it needs to be used at the right place at the right time, because there is an expense with that, and indeed the storage issue, you're saying, so that there is a time and a place, etc. And finally, the video was very impressive, and I think I will take a trip to East Kilbride now to have a little walk down to the sea. I didn't realise we were on a lovely peninsula with East Kilbride, so it looks lovely. But seriously, it was the video was really helpful, and it's quite amazing that it was able to the amount of data when you think of what that's showing and the level of detail, how that was able to do that, and it was very helpful to kind of see that and knowing that the actual data is behind it. It's not just a film. There's so much happening. You can use that for behind that. So on behalf of the Edinburgh PWI section, Colin, I'd like to thank you for your time tonight, and indeed for the excellent presentation. So this is the first ever Edinburgh virtual presentation, and we would normally show our appreciation in the normal manner by clapping our hands. So we will have to show our appreciation in the new normal way, I suppose, by I'll clap my hands, and I'm sure the rest of the audience will join us. Thank you very much, Colin. Thank you.
Steve, right in the afternoon now.
Absolutely.
Yeah. Thanks for that, Colin. I thought that was originally large. You're showing us over the sea behind it.
Absolutely, yeah.
You're not the only people that mentioned that, but yeah, I didn't realise it was sea because it's been colourblind. I thought it was green.
It looked very pleasant. So thank you again, Colin. And just before I wrap up, there was just for next month's meeting, so we are no doubt going to be online again, type of thing. And the meeting is on Thursday, the 8th of October. And the subject is next generation cast manganese crossings verified by computer modelling and unique physical testing. And the presentation is by Hannah Pearson of Progress Rail, one of our Edinburgh members. So that sounds an excellent presentation as well. So we look forward to seeing everyone, or at least virtually seeing everyone next month. And thank you again, everybody, for attending tonight, and hopefully see you next month. Thank you.
Thank you very much.
Thank you. Thanks, bye.